Hello! So many people still alive. Are you tired? I'm tired. But we will manage through this last talk and then you are free and you can go home. I'm going to talk about Google AppEngine and how I was serverless before it was cool. And it's very funny that my talk is right after Amazon Lambdas. I'm a technology director of digital agency Multimedia Atelier from Prague, Czech Republic. I'm a founder of FNX.io, which I call backend studio. We create custom backends for your frontends. And I'm a Google developer expert for Google Cloud Platform and also for Dart. It's not that I'm employee of Google or it's not some kind of certification or something like that. That simply means that I know some things and I am not afraid to talk about them, so that makes me an expert. Thank you very much. So Google Cloud Platform is a quite big set of different APIs, utilities, services, and databases you can use, but I am going to talk only about this small piece, and you will have to store our data somewhere. So I'm going to talk about AppEngine and data store. Who is Java developer here? That's great. And who is using AppEngine? One person. Do you like using AppEngine? You just tried. Okay. So what is serverless? We had a whole talk about serverless. In general, you write a function, you push some button, maybe you sacrifice a goat or two as we've seen, and then magic happens and your function is living in the cloud and gets executed when it's needed. So on how many virtual machines are you using? What is your IP address? How is your hardware doing? How is your disk space? You don't know anything of that, and you don't need to know. It just works, so you don't care. You don't have any operations. You just deploy your code to the cloud, and then there it lives, and everything runs without you needing to do anything else. So I like that approach. Actually, I'm using it since 2009 for 8 years already. So I can recommend AppEngine to you. I think it's quite old technology for now. It's still evolving and still going forward. And I don't think they are going to kill it anytime soon. So AppEngine, fully managed platform as a service. Platform means that you have to use their APIs, their services, and you have to respect some limitations. For example, you cannot start a new thread, you cannot access file system, you cannot, I'll get to it later, but there are some limitations. And if you respect those limitations and you create your application like that, then it's scalable and they will auto-scale it for you. So what you can use, what I can use in AppEngine, Java, PHP, Go, Python, .NET, Node.js, blah, 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 blah. I can literally use anything. I can obviously store my data somewhere, so I have a SQL database, NoSQL database, some kind of in-memory database for caching. is Google service, so I have some full text service I can use to index my data. I have cron for scheduled periodic tasks. I have asynchronous queue for tasks which need some more time to get finished for some, I don't know, some backend data maintenance, for example. And I can deploy my application to AppEngine in different versions. So I can either perform some A/B testing between two versions of my application, or I can slowly transform traffic from one version to the other version. And if anything happens, I can easily go back to previous version. I have CDN there. I have HTTPS certificate for free. I have access to all the logs. I can configure monitoring. I can configure security constraints so that only administrator will be able to access some URLs. I can have multi-tenancy. I can sandbox parts of my application so that the user with access to this part of data will never have access to some other data, to data of other user. Even when I make some mistake, it's all sandboxed and I can see only what's mine, for example. And with the functions, without taking care of virtual machines and disks and hard drives and I don't know, IP addresses, only developing, no operations. With this simple command, gcloud app deploy, I can deploy my application to the cloud magically, and then there it lives. So let me show you a little demo. So I have two small applications. First one is just a static website. You see index.html, that should be familiar. This is index.html. Oops. AppYAML. What is AppYAML? It's a deployment descriptor for our application. In this case, I used Python 2.7. I don't know Python, I just copied some Hello World example. Sorry about that. And deploy script. gcloud app deploy project FNX GCP demo version static 01. Project ID here is something you can obtain from Google Cloud Console. If you are using, for example, Google Maps, you probably know that you create a project with project ID. So it's the same mechanism here. It's the same project ID. So let's deploy our mighty static application to the cloud. Yes, I want to continue. Updating. Notice, please, that I'm not killing any goats, right? It will happen without any unnecessary violence. Let's hope. And I can always blame the internet connection here. No, it finished. So deploying to URL FNX GCP demo appspot.com. Appspot.com is default address for your applications, but you can change it and you can map it on your own domain. And HTTPS, well, it's their domain, appspot.com, so they can create HTTP certificate for you. And hello, welcome to Hello World Fest. That seems okay. Well, it's not a big application, but still, it's in a cloud, right? So let's continue. You have two options in AppEngine flexible environment and standard environment. What you have seen just now was standard Python application. Flexible environment is quite new in AppEngine. It's based on Docker. You can apt-get almost anything you want to your Docker image. It's useful when you have application with consistent traffic, but it auto-scales as you expect. And you don't care about virtual machines and stuff like that. It will simply run. And you can use anything. If you are able to write Docker file, so you can deploy it to AppEngine. Standard environment, on the other hand, works only with those 4 languages: Java, Java 7, PHP, Go, Python. Your application lives in some kind of sandbox. It has some limitations. For example, you cannot write to file system, but it can run for free or for very low cost, and it's useful for applications with inconsistent traffic. For example, if you know that your users are from this time zone and they are accessing your application during lunch, for example, and after work, and they are asleep at the night, you need quite a lot of elasticity for your application, and you don't want to pay resources during the night which you don't spend. So this is exactly something for such use case. The flexible environment, if it runs in a Docker container, you can run it on AppEngine. You have to do 2 things. You have to listen on 8080 port, so your application must run on 8080, and you must reply to health checks. It's root / health, and you are supposed to reply with HTTP status 200, but it's not difficult, because this health check is used by auto-scaling mechanism to kill or not kill your not code, but instance. But in flexible environment, you don't have access to all those APIs like multi-tenancy and cron and I don't know, asynchronous task and stuff like that. They are all tightly embedded into standard environment. So I prefer standard environment, and I am going to talk about standard. So it's Java, so the web application you are creating is .war package, and exactly the way you creating your applications for Tomcat or Jetty or whatever, you take this .war file and you upload it to AppEngine and you are done. That's your scalable AppEngine application. What you need is a Google account. You need to sign up for Google Cloud Platform. You have to create a project, and you will need AppEngine SDK and probably IntelliJ IDEA plugin or Eclipse plugin or something like that. Everyone who gives me 5 stars will receive $300 credit at the sign up. And you will have 1 year to spend those money, and I can guarantee you that you will have troubles to spend $300 on AppEngine. To be completely honest, everyone who signs up for Google Cloud Platform will get $300 regardless of your rating of me. I tried, yeah. It's Java application, so it's probably written with Maven. So this is fragment of our POM XML dependency on AppEngine SDK. Okay. It's a .war package, so you will have to create web XML in your webinf directory. And also you will have to create AppEngine web XML. It's like a vendor specific deployment descriptor. You will say your application ID. You can say your version. This is completely up to you. Just write whatever you want here, as long as it is string. And you can set up system properties, environment variables. And maybe you will need them to, I don't know, tweak your behavior as possible. Okay, another demo. So, second demo, Java application. Java minimal application. Again, index HTML. Okay. Webinf, because it's Java application. Web XML. It's not complicated application, but it's late and you are tired, so what? And AppEngine Web XML with our configuration for AppEngine. Again, very easy. Maybe you have noticed that this is a Java web application without any Java code. It's quite significant. But still, it's a valid Java application, right? And we have another script here, local. So when you develop your AppEngine application, you probably cannot deploy it with each build to the cloud and check if it's running okay and if you are using all services of Google Cloud properly. You can run your local emulator of AppEngine. So let's do it. It will boot up. It actually does a pretty good work of emulating real cloud environment, even with some network problems within the cloud infrastructure. So if you are developing on localhost, you are quite ready for deploying to the cloud. Localhost 8080, okay. Okay, it's running. Let's deploy it. It will take a little bit more time, which I will use to refresh myself. Scanning for JCP files. If you have any JCP files in your application, it will compile them and make servlets of them, so they won't get compiled like they do in Tomcat with the first access. That's something you don't want to do when your application is starting, because you want to start your application as fast as possible. So let me check again what we did actually. FNX GCP demo Java version 01. So the URL should be the same. FNX GCP demo. But it's not working. It's still the previous example. What happened here? Who knows it? Who is paying attention? No one. Never mind. I deployed the Java application as a different version of our application. So this is the active version, static example from previous. And this is our new version we deployed right now. And you can see that all traffic is allocated to the previous version. This feature is priceless. It happened several times that we had to roll back one version to the history because someone messed something up. It happens. So in this case, I'm quite confident, and I will just migrate all traffic to the new version. Nah. Thank you for your spontaneous, well, Java demo. Okay, let's start some serious work here, coding. So we have our application in Java. We have a deployment descriptor. We probably should start with some serverless or whatever. We should definitely start using AppEngine SDK itself to leverage the cloud potential. Memcache, I was talking about Redis. It's not Redis, it's something very similar. Memcache, you use it like this. You just put something in the cache and you read it back when you need it. It's quite important service. It can speed up your application quite significantly, and you should use it. So don't avoid it, use it. And you will have to save your data somewhere. You can use SQL database. They have managed versions of MySQL and Postgres. But they seem expensive to me because you are paying for running machine. On the other hand, the data store, NoSQL with transactions, which is nice for NoSQL database. I can run SQL-like queries on the data in data store. I have indexes for fast queries. I can access it with JPA or JDO, and it's fully managed, again, without me taking care of virtual machines or paying for virtual machines. I'm paying only for real usage. So, for example, 100,000 reads from data store costs 6 cents. It's not much, right? So I'm using data store. And also it's NoSQL document-oriented, schemaless. It feels faster. Like for development, I can develop more quickly without taking care of outer table. You can use JPA or JDO, but it has low-level API. Data store is actually just a huge hash map of hash maps. So Mr. Salieri here is one hash map with those 3 keys. This is his primary key. This is a kind of the entity, so I can have my documents in different kinds. And I can save him to the data store and read him later. But I don't recommend to use this low-level approach either. Use Objectify. Objectify is a third-party library recommended in AppEngine documentation. And the guy who wrote it just knows everything about data store and everything about AppEngine, so he created something which works really nicely, and he uses everything you want to use in that combination, AppEngine and data store. You just create your plain old Java object, you throw some annotations at it, and that's your persistent entity. You can save it, and you wouldn't believe it, you can read it later. What Objectify does is that it goes through Memcache. So you pay for storing and reading data in the data store, but in basic setup, Memcache is free. So it's quite possible that you won't pay for your request like at all, because you will obtain the data from the cache. and you will send it to the client, and you will never touch the data store. You will pay something because you are also paying for some CPU time. It's not like CPU is for free. And this works without you having to do anything special. You don't need to configure anything complicated, nothing. You use Objectify, and it does a pretty good job managing consistency between Memcache and the data store. So, of course, the data won't be as consistent as would be if you are reading from the data store directly, but it will be good enough. And the difference in price is significant. AppEngine or data store also supports transactions, and Objectify allows you to write them like this. You create a block. It's actually atomic block, something which will be applied as a whole or not at all. So if some of these statements fails, then all gets rolled back and you can try it again. So use it. Use transactions, especially when you are, I don't know, handling some financial data. These are like full-blown ACID transactions. It's guaranteed that it will either execute as a block or not at all. Consistency. So when you are reading by primary key, data store is strongly consistent, so it will return the data you've just put into it. If you are running a query without specifying exact ID, but you are searching for documents or entities with some property, it's possible that you won't receive the entity you've just written into data store. They call it eventual consistency because eventually it will be consistent, but it will take some time. So don't be surprised when you, I don't know, send a comment on some article in your application. Then you read all comments and your comment isn't there, but there are ways around it, and I can live with that. Optimistic locking, that means that when you open your transaction during the commit stage, if someone managed to change the data faster than you will receive concurrent modification exception, and you can try again. And another complication is that it's possible, as they say, in very rare cases, that you will receive exception from the data store, but still the data managed to get through and will be written there. So your transaction must be idempotent, which means that when it's run again, it won't get applied twice, for example. You have to write your transaction so that if it's run twice, the result will be the same. Again, with this, like retrying your transaction, this might happen sometimes. Objectify will manage all this for you, so you don't have to take much care about it, but you should know what's going underneath. Another useful tool, task queue. So your AppEngine request must finish within 60 seconds, otherwise it gets killed. Also, I wouldn't recommend to let your user wait for longer than 60 seconds. So it's a good practice, but sometimes you really need to spend some more time with your data, and you can use this this queue of tasks. Each task is actually URL in your application. So what you do is you are just telling the task service, please call this URL with this parameter sometimes in the near future. And when it does, you process the request as it's from user. And if you return 200 HTTP status, everything is fine. If you return some other 400, 500, the service will try it again later and again and again until you come to senses and respond with 200. You can have several queues with different behavior. You can configure threshold, or not threshold, pace rate, how many requests you allow to go through the queue, which might be useful. And some tips how to work with data store and generally in your AppEngine application. So data store doesn't have unique indexes. The only thing which can be unique is primary key, and occasionally you need some unique index. So in this case I have users with primary keys and they have emails, and I want those emails to be unique in my database. So I can create second entity just next to it, and the email here will be the primary key, and the only other column in this table or entity will be identification of the owner of this email. And I can work in transactions. So as long as I'm modifying those two entities in transaction, I should be consistent, and I can be sure that all emails are unique in my database. I could also use email as a primary key right here with the user, but it would be complicated then for the user to change his email, right? So there is a way around it. Hydration. So let's imagine we have some content management system, some articles. I'm sorry about the goat topic, really. It just happened, I don't know how. Sometimes these things happen to me. I have articles with some authors, obviously, and I want to list articles with the name of the author. So I can iterate through the list of articles and get from data store information about the author. It's called N+1 problem. When you create one query, and then n other queries to fetch the details. So don't do that. You have two possibilities. First one is denormalization. You are not in SQL database and nobody is watching you, so you can easily copy the name of the author to the article itself. Why not? Or do the hydration in multiple steps. Iterate through your articles, collect all user IDs you will need, fetch them all together in one query, and then iterate again and populate the data to the listing. That should be quite faster. Performance. Basically, the memcache is for free, but no guaranteed capacity, no guaranteed performance, with nothing guaranteed. It works, they give you some memory, but if you are feeling that your application might be a little faster, try dedicated memcache, especially when you are using Objectify and writing and reading through memcache. Dedicated memcache with some guaranteed capacity and guaranteed performance can make a big difference in performance of your application. So rather than throwing money at, I don't know, not CPU, but you can choose your VM. So rather than building bigger VMs for your application or configuring bigger VMs for your application, try dedicated memcache first. You should see the difference there. So what do I use? Well, it's a Java application, so I need some dependency injection. I do not recommend to use Spring because it seems to me that it has quite a slow cold start. It takes a long time for Spring to boot up, and it's not a good behavior in the situation when you want to spin up some instances and then kill them and spin up some more, and you need something which boots a bit faster. So I'm using Juice dependency injection container. I'm using Jersey for APIs. You can use REST easy or something like that. I'm using Objectify for accessing data store. And there is just some business logic implementation in it. It's all glued together with Juice, and that's it. Like no magic and no goat killing again. But this is probably something you are familiar with if you are a Java developer. Limitations. No disk access. No threads. Actually, you can run a thread, but it must finish before the request itself finishes. Otherwise, your thread will be killed. You can use reflection only on your classes, so you cannot modify Java long integer. Limitations of data store, well, it's NoSQL database. You have no joins. Eventual consistency for global queries might be limiting. But I can live with all this, and well, it's a price I'm paying. But I don't have to take care of the application like at all. I build a WAR file and I deploy it, and then it lives and my work is done. Pricing. Yes, you are paying for CPU. This is just a fragment. Actually, everything in AppEngine has its price tag. So this is just fragment of 50 rows of this table. Here you can see that you pay 18 cents per gigabyte for data stored in data store. First 50,000 reads from data store are for free, then you pay like nothing. First 20,000 writes are for free, then you pay something. They are very transparent about the pricing. If you are logged in and you are administrator of this application, they give you estimate for your request. This is Chrome Dev Tools. AppEngine estimated cost per 1,000 such requests is nothing. This is probably a situation when I directly hit memcache, receive the data, and I'm going back and I'm not paying anything. Take it, Google. One more tip for you, and it's not directly related to AppEngine, so maybe if you have some questions about AppEngine, we can start with them, and then I will have my last tip for you. No questions? Okay, so some questions.
I just have one question. Is there some kind of rate limitation you can configure for your backend services. Otherwise, you can abuse it and spend all your money.
Yes, you can set up a daily limit of the money you want to spend. So you can say, no matter what I don't want to spend more than $2 a day, and then you can set up some monitoring and discover what's going on wrong and why. Fine tune your application, optimize it a little bit, or throw more money at it. It's always possible. Next question.
So regarding the local development, and so you have the local data store, and how do you manage the data? Can you use test data? Do you use some kind of integration testing framework for local testing, or how do you manage testing?
There are some mock-up stubs of application of AppEngine services, so you can write unit test and see if the mocks are called as you expect. And what I do is that for each project I create exact copy in the cloud, and then I write some command line robot to not only emulate the like full integration, but I also emulate some load. And it's probably not the smartest or most elegant way to do it, but it works for me. So.
Okay, so it's again against the environment. But how do you manage data migrations?
Data migrations.
Yeah, what kind of structural changes in data? Does this Objectify support?
Yeah, they have some special annotations which allow you to first. They make things easier for you when you are changing column names, for example, and changing entity names and so. But occasionally, when I need to completely restructure the data, I will just build a task and execute the task and rebuild the structure. But I'm trying to avoid such situations.
I have a couple of questions. Can I move my code from AppEngine to my dedicated server if, for example, my app become highly popular overnight and the load increased exponentially? So to avoid some additional charging, because charging in serverless architectures also rises exponentially. So it would be cheaper to have own dedicated server if load increased.
I don't believe that. I know what your question is, and I will answer it. But I don't believe that you will have cheaper hosting by yourself. If your application is under consistent load, then maybe. But if you want some elasticity in it and you have some traffic spikes in it, it seems to me that it's much cheaper to have like one small virtual machine in the cloud, and when it's needed, 100 virtual machines in the cloud for 20 minutes and then downscale, which will happen automatically for you. But yes, you can take your AppEngine application, take it outside, but it would be probably painful, and I didn't try it. There is some third-party image of AppEngine you can boot up and then use it as an AppEngine on your server.
Yes, we actually tried, but it was back in 2011 year, and it was really painful experience.
Painful, yeah, I told you.
And also, I have a question about that $300 tier. Is it allowed to use it for commercial apps?
Yeah, it is. I'm not sure if it's completely like without limits. Maybe you are not allowed to mine bitcoins with it. I'm serious about that. It's not a joke. I think you are not allowed to mine bitcoins with those $300. But that's all.
Okay, thank you.
Question?
5 minutes.
Thank you. But question? 5 minutes.
How does AppEngine compare to Google Cloud Functions?
Google Cloud Functions allows you the same thing as Lambda, or maybe a little less functionality. I don't know, I don't use it. So you can write your JavaScript function and deploy it, and it will be triggered occasionally when you need it. How would you like to bundle your functions all together in nice package? And write them in Java and call them .war package and upload them like that.
There are frameworks that support this, where you can bundle your functions into modules and deploy those. Like the serverless framework, they will do it for Lambda, and also looking at the Google Cloud Functions deployment.
Biggest advantage of AppEngine standard environment is that set of all those features you can use. You cannot use them outside the standard environment, task queues and cron and all these things. You will need them, you will use them, you will be happy that you have them in AppEngine, and you don't have this with Google Cloud Functions. You are a fan of JavaScript or what?
No, not particularly. You can do Java on Google Cloud Functions as well.
Yeah, you can?
Yes, you can.
So you should be here and talking about that. Well, sorry, I don't know Google Cloud Functions that well. Can I have my slides back? I have important message for the audience.
4 minutes.
I can do it in 4 minutes. So what we do is we create backends. You create your front end, and we create backend. If we can, we do it on Google AppEngine, as you understood. Yep. But there is this little thing which is very painful, and customer is usually expecting us to create some kind of content management system, some tool to access the data. So completely out of topic. Let me say this. So Java developers, again, hands up. Who is Java developer? Who likes JavaScript? Keep your hands up. Of Java developers, about half of Java developers. The other half, have a look on Dart. It's existing alternative. It's production ready. We use it. Angular Dart. It's no beta. It's ready to use. We create these beautiful backend administrations, and with combination Dart, Angular Dart, AppEngine, the development is faster than I have ever seen before. It's like really, really fast development. So have a look at this. Thank you. Okay, I don't have time to show you the console, so that's it. Any more questions? No. Okay. Yeah, one more.
So regarding this RAD thing, Angular Dart. So do you use some kind of a kind of scaffolding mechanism so that you give the entities and you get the admin forms out of it magically, or with help of some goats maybe?
No, it doesn't work for me like that. I don't believe in this approach. So we write it by hand, and every time the screen is little bit different, and it's better for user experience than to have like 100 same screens. So we write it by hand with some tools and with some Angular Dart components of we created last year, and I can show it to you later. It's probably too off topic for this audience. Thank you, audience.